Now, as we move into Module 5, we're going to be dealing with the quadratic equation and some other ways other than factoring to solve. One of them will be the principle of square roots, another completing the square, and we'll have some problem solving. So, with that in mind, let's get started. A way that we've used before to solve an equation like this is to take the x squared and then put this over to the other side and, in a sense, put it in standard form. And then, since this is the difference of perfect squares, we would factor it and get the conjugates x plus 9, x minus 9, equal each of the factors to 0, and we get x is a negative 9 and x is a positive 9. Now, when we have quadratic equations, and here we see it's to the second degree, we need two answers. Alright, sort of keep this in mind, because now what we're going to look at is another way. Now that we've worked with radicals a little bit, and if we have x squared equals 81, the way it's shown here, if I take the square root of this side now, that would give me x. Now if I take the square root of this side, that would give me a 9. But notice I'm only getting one value. So the rule we'll bring into play at this time is that when you take the square root of a x squared, in order to ensure you get both answers, we'll put a plus or minus out in front, and we'll get a plus or minus 9. Now we get both answers. Alright, let's look at example B. Again, we want to isolate the x squared, so we're going to divide both sides by 4. This gives us x squared equals 7. Now, again, using this technique, we take the square root of this side. That'll give us x. And then we'll take the square root of the other side. That'll give us plus or minus the square root of 7. And those are our answers. Now, in this case, we want to isolate the x squared. So I like to have a positive x squared. So I'm going to switch this around a little bit. I'll put the 3x squared on this side, and that will equal 5. And then swing it back to this side. 3x squared equals 5. Now to get the x squared by itself, divide both sides by 3. I get x squared equals 5/3. Now, if I want to use this same technique, I'll take the square root of this side, plus or minus the square root of that side, and then I get x equals plus or minus the square root of 5 over the square root of 3. Now, we don't like to have a radical in the denominator, so here's a case where I will rationalize the denominator by multiplying it by 1 in the form of the square root of 3 over the square root of 3. So this then becomes plus or minus the square root of 15, And then this is the square root of 9 that simplifies to 3. And there's the answer to letter C. Now you might say, isn't this the answer also? Well, as I say, we don't like to see a radical in the denominator. So pretty generally, we rationalize the denominator, and that's why I showed you this technique here. Okay, let's move it up. So now we can see that equations that we weren't able to factor, we can now solve them by using this technique. So we have 16x squared equals a negative 49, transposing that. We're going to divide both sides by 16. Here they cancel out, and I get x squared equals the plus or minus the square root of 49 over the square root of 16. Now 16's a perfect square, so I take the square root of this side again, gives me the x, square root of that side gives me this. But notice, and I have a negative there, I have a negative value. So the square root of a negative 49, you recall, is the square root of a negative 1 times the square root of 49. Square root of negative 1 was I, and this is 7. So our numerator up here becomes plus or minus 7i, and that is over the square root of 16, which is 4. So again, this wouldn't factor, but by using this technique, and these are not real numbers now. In the old days, we'd say, no, there was no solution. But now we've added complex numbers, imaginary numbers, to our tool bag. We have an answer for this. All right, let's go on. Looking at letter E, what we see here, this is a perfect square trinomial that will factor into x plus 2, the quantity squared, equals 10. Now, since this is a square, we can take the square root of this side and then plus or minus the square root of that side. So we then end up with x plus 2 equals plus or minus the square root of 10. We take our 2, bring it over, we get x equals, now our 2 over there is a negative 2, plus or minus the square root of 10. And these are our two answers to this quadratic equation. Now this is a new type of solution for us, where on this side we ended up with a square of a binomial that we could take the square root of and use this principle of taking the square root of both sides. So a new technique here which we'll build on. Now it's a little strange. They gave us that earlier one where we had to factor the left side to get this, because now in this example they're saying x plus 4, the quantity squared, equals 5. So what technique would we use? Well, we're going to take the square root of this side and then plus or minus the square root of that side. So when we take the square root of a a base that's to the second power, it just becomes the radicand. X plus 4 equals plus or minus the square root of 5. Now, how do we get x by itself? Well, we take our positive 4, transpose it, becomes a negative 4, plus or minus the square root of 5. So we're building up toward a new tool for our toolbox. Now, suppose we can get the left side to become a binomial square. Can we use this technique? And the answer is yes. So that's where we're going. Now they're giving us a few practice problems in which we have the start of a perfect square trinomial, and they want us to see if we can make it into a binomial square. Well, let's look at this that we have here. We know that this down here would be an x. From our recipe, square this term, it becomes this. Now we take this term, and by the way, there's a plus there, and this term, and do what? Multiply it and then double it to get this term. Now we should have this as a reference here. A x squared plus bx plus c. This is the standard form of the quadratic equation. And our a is 1 here, so actually we probably can take that out of there. Okay, so we're asking, how did we get this 10, which is in essence our b term? Well, we multiplied this times what was here and then doubled it. Well, if this is the results of doubling, what do we do to our b term to get this term here? Think about it. If we doubled it to get this, the answer is we divide by 2. So this will be a 5 that goes there. So we can check it. Multiply these two together and then double it. Yes. Now, how did we get the c term? Well, we said we square this term, and that becomes a 25. We have now made what is called a perfect square trinomial. We have, in essence, completed the square. That's a process that we're going to use, completing the square. So over here we put a 5. Now let's try it again. Now I like the technique of you have what you have here, and then you put a parenthesis underneath it that you will square. It's just this over here. Now we know this term is going to go right there. Now this is our b term. How did we get it? Well, we multiplied and then we use a negative here. This times what was here, and then we doubled it. So we need to multiply a negative 9 by 1/2, or just divide the 9 by 2. So this becomes 9/2, which is, if we multiplied it, would become 9/2. Now, how did we get our c term? Well, we squared this. So this would be 81/4. And over here we have a 9/2. So we have completed the square. That's the name of this process that we are developing. Okay, keep this in mind, and again you'll have some practice, and quiz me on it. Now, a technique that we're going to use to solve quadratic equations, this doesn't factor, but we're going to use the technique called completing the square. Now, there is a recipe, and for some you may have to go back and watch this again, but this is how it works. The first thing we do is write this. That's this and this. We take our C term and move the C term to the other side. So just by changing the sign, -8, which is our C term, goes to the other side as a +8. Now, the technique I like to use is to put a parenthesis where we're going to complete the square by getting our two-term binomial. Well, this x comes right down here. The negative sign comes right here. Now, we got our b term by multiplying these two together and doubling it. So what do we do there? We're going to divide this by 2, and we get a 3. Now, how do I get my C term up here? And I'll change colors to illustrate that. And the answer is we square this, and that gives us a +9. Now, this is no longer an equation because I've added a 9 here. But if I add a 9 there, I now have still an equation. And when I factor this, which is now a perfect square trinomial, it factors into this. And I add 8 and 9, and I get 17. Now we're back to the situation where I have a binomial that's squared equals 17. So what do I do now? Well, I take the square root of this side and then plus or minus the square root of that side. And now this becomes x minus 3 equals plus or minus the square root of 17. I transpose my -3 to the other side where it will become a +3 plus or minus the square root of 17. And how did I solve that? Well, I solved that by completing the square. What are the steps again? Well, it's in standard form. I take my C term to the other side. I put a set of parentheses in which I'm going to get a binomial that I'll square. I take half of my B term to get this term here that I will then square to get my new C term. And to keep it an equation, I have to add that to both sides. And again, factoring this becomes this, and then I can take the square root of both sides, plus or minus on this side, then transpose what is with the x, and that gives me my answers. Now this one was pretty easy because our b term was divisible by 2. So let's go on and try another. And this one here. So again, it's x squared plus bx plus c. So that's the form this is in. So I'm going to write x squared plus 3x, take my c term, and move it to the other side as a +5. I'm going to put a set of parentheses that I'm going to develop a binomial that will be squared. And I know my x is here. This is going to be a plus. I'm going to take half of 3. Half of 3 is just 3 halves. I just divide the 3 by 2, or multiply it by 1/2. Now what I need to do is get my new c term up here, square this, and this becomes 9/4. Now if I'm going to keep this an equation, I must add 9/4 to this side as well. So now this is an equation. And when I factor this, this is a perfect square trinomial, it will factor into this. But in order to do what I have here, I have to change this 5 into something with a denominator of 4. So I multiply this by 4/4, and I get 20/4. 20/4 is equal to 5. But I have to have common denominators. So I'm just going to erase this here and put my 20/4. So this now becomes 29/4. And there I am. So now my next step is I take the square root of this side, which will just give me my radicand, x plus 3/2, plus or minus the square root of this. Now, as I do this, I notice I can take the square root of our denominator. That's a perfect square. So this is going to become plus or minus the square root of 29/2. Okay. Now to solve for x, I just take this, transpose it, and I get x equals, now on this side, this is a negative 3/2 plus or minus the square root of 29/2. Now, since I have common denominators, I can also write that all over 2, and this would be like a negative 3 plus or minus the square root of 29 all over 2. Okay, that's not too bad yet either. Now, to use completing the square, we need to have a 1 for our a term up here. So in order to have a 1 here, I have to divide every term by 2. So this then becomes a 1, and I'll just erase it. And then I have this. So my next step is I have to take my c term to the other side. So I get x squared plus 9x/2, and this becomes a positive 3/2 on this side. Now I use the same technique, it's just a little more tedious. I'm going to make a parenthesis that I'm going to square, eventually having a binomial. This is the part where we call completing the square. Now we know the x goes there, the plus goes there, and then to get my b term that will eventually come from here, this is what I have now as my b term. So I have to take half of that. Well, half of this I just go half of it. So this down here now becomes 9/4. I'm taking half of this, so if I took this and doubled it, I'd get this. So half of this is 1/2 of that. Now, to get my new C term, I have to square this. And here's where it just gets a little complicated. This is going to be 81 over 16. Now I added 81 over 16, so over on this side I have to add 81 over 16. Now, in order to be able to group these together, I have to have this denominator a 16. So I have here 3/2, and I want my denominator to be 16. What do I need to multiply that 2 by? Well, if you said an 8, that is correct. And it's a 1 in the form of 8 over 8. So when I do that, this becomes 24/16. So I'm going to change this now to 24/16. And you saw how I got it. Now, when I add 24 and 16s, I get 95. No, I get 105, I believe. Well, that's a 5, yes, 105 over 16. So, this is where we are. So I pause to check my work, and this is good now. So, we're going to take the square root of this, and then plus or minus the square root of this. So, let me put it up over here. I get x plus 9/4 equals plus or minus the square root of 105. Now, what is the square root of 16? 4. So I can do that. Now, to isolate the x, I'm going to take this term to the other side, and I now get for my answer x equals, on this side this is a negative 9/4 plus or minus 105 over 4. And if I wanted to write that all over, it would be negative 9 plus or minus 105, the square root, okay, can't forget my square root sign here, over 4. And that's the answer they have down below. So again, this was sort of tedious. And we might say, is there another way to do this? When you have in our a value a 2, you want to have it a 1. Well, we did that, but that was sort of tedious. Lots of fractions and things. And in our next section, we do have a way to do this. Now, the answer comes out the same. It's just done a little different way. This is very easy to use, completing the square. This one wasn't too bad. This one was a challenge. All right, let's go on to our... Now, for this one, we have Carlos investing this at an interest rate, compounded annually. In 2 years, the amount has grown to this. What was the interest rate? Now, to do this example, we need a formula, and I put that formula right here. So for convenience. So let's go on and work it out. Now, the amount is this 3630. It's grown to this amount. The principal is 3,000. And we multiply it by 1 plus the rate that we don't know. but the time is 2 years. So we've just substituted into this formula the information they gave us here. So the first thing we do, and take notes on this, so if you have one like it, you're going to get rid of the 3,000 by dividing both sides by 3,000. This cancels out. And over here, we can leave that like that because we're going to use a calculator. So we have this 3630 divided by 3,000 equals, in parentheses, 1 plus r raised to the second power. Now, we want to get rid of something to the second power. So how do we do that? Well, using the technique we just had, we can take the square root of that. And that will become 1 plus r. Just the radicand. When this index number is the same as the power we're raising it to, it just becomes the radicand. Now we take plus or minus the square root of this side. Now, since we're not really interested in the negative value, we can just get rid of that one. We don't want that one. So, what are we going to do now? Well, we can subtract 1 from this side. It's going to be r. And then when we get this, which is our answer here, when I do that, it's going to be, when I take the square root of what I have here, it comes out as plus 1.1. When I take the square root of this, just put that in your calculator, you get this. Now, when I take this 1 here to the other side, let me change the color. This 1 to the other side becomes a negative 1. So I have now r equals 0.1. Now this is a rate. Right now it's a decimal fraction. What will be the percent of 0.1? Well, we make something a percent by moving the decimal place over 2 places and add a percent sign. So this will be 10%. So what was the interest rate? Using this formula, 10%. And we substituted. We divided the 3,000 by both sides here. Then we took the square root of this to get rid of our exponent. We eliminated the negative because we're not interested in the negative. That's a possible answer, but it doesn't apply here. And when we subtracted a 1 from this, we got 0.1, which is 10%. Well, for something like this, we could make a little picture if you like. We have an object that's going to fall 740 feet. And it's defined by this formula. So basically it's 16 t squared equals the distance in feet of 740. So how do we solve this? Well, we want to solve for t. We want to know to the nearest tenth of a second, and t is time. So we divide both sides by 16, and we get t squared equals this, Then we take the square root of this side to get t. And again, where you go plus or minus this, just put that in your calculator. Take the square root of that, and we can eliminate the negative, because we don't have negative time. So we can take that one away. And we get for an answer 6.8 when we round it to the nearest tenth of a second. Now you should try this to be sure you're getting these answers. And I just checked it with my calculator, and it's a couple more zeros here, so we would just drop those. And it's 6.8 seconds. So a nice easy one toward the end, but you need to know how to put this into your calculator and the strategy of what's going on. Okay, we'll be going on to topic 2 of Module 5, which deals with the quadratic formula very soon.